Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 3. In the last video, we have already discussed question 1 and today's lesson we will start from question 2. As always we will discuss these questions in detail so you can improve your understanding of practical skills in physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 2 says, a student models a safety system used on a railway. Two parallel 30 centimeters copper rods model the rails. These rods are fixed 5 centimeters apart and are connected to an ohm meter. A movable copper rod models the train. This rod completes the circuit with the ohm meter as shown in the figure. As the distance x varies, the resistance capital R of the circuit varies. For part A, describe how student could determine accurate values of x and R. So we need to determine accurate values of x and R. So first of all, we need to understand what kind of problems can cause uncertainty. If rod is not perpendicular, may rod is not perpendicular, so we can say may rod is not perpendicular. So this can be a problem and this can cause uncertainty. So rod may not be perpendicular. And so how we can make this rod perpendicular? So first of all, let me show you if rod is not perpendicular, how this will look like. So simply we can imagine this one is the rod. If this is not perpendicular, so this rod, let me draw again. So if this is not perpendicular, maybe we will see this one like this. So this is not perpendicular. And also this rod can look like this. We can draw another one. So it is possible the rod is like this. So we can say the may rod look like this. It just exaggerated. Now the question is that how we can make this one perpendicular. I mean this angle has to be 90 degrees, this angle has to be 90 degrees. So how we can make sure this angle is 90 degrees? We can use for this purpose, we can use set square. So we can use set square. So let me first of all clear this one. So it's hard to clear but we can draw. So we can use set square. So simply we can draw our set square here. So this one is the set square. So we can place set square here. We can also place set square here. So with the help of set square we can check is this angle is 90 degrees or not. So we can use set square. About resistance, what kind of problems can make resistance inaccurate? Means it can increase the uncertainty. The first thing can be the zero error, means ohm meter is not starting from the zero, so that can cause uncertainty. And also if these rods are not clean, so we can say rods not clean. If the rods are not clean, that will also give us different value of resistance. Different values, so means if there is a dust, value of resistance will be different than actual value of resistance. So these are the problems we can face. So how we can improve this one? We can check for zero error and also for one value of x, we can repeat experiment. For one value of x, we can repeat experiment and we can calculate average resistance. We can calculate average value of R. And so in this way we can improve measurement of R. We can get more accurate value of R. So we can clean the rods. We can say clean the rods, check for zero error. So these are the points you need to understand. Very practical thing. When you need to measure resistance, always make sure ohm meter starts from zero, means there is no zero error, and also make sure connections are clean. And also it's always good way if you repeat the readings for same value of independent variable. We repeat the values of dependent variable. We can then calculate, and then finally we can take average. So these are some very good points you can use for electricity experiments, and also you can use for mechanics experiments. I hope this one is clear to you. Now let me show you the answer, how you can write down your answer. For your answer, simply you can talk about these points. You can say measure x with a meter rule, because this is 30 centimeters. You cannot say you will use vernier caliper, or you cannot say you will use micrometer. So you have to use meter rule, or you can say measuring tape you can use, because this is greater than 15 centimeters. So you cannot use vernier caliper. Ensure the movable rod is perpendicular by using set square. We have discussed this point. Check for zero error on ohm meter. Repeat capital R readings. Calculate mean R for same value of x. Means for one value of independent variable, we can take more measurements of dependent variable, and then we can take average. Ensure rods are clean to minimize contact resistance, and this one you can use for any electricity experiment. Clean the contacts, so it will minimize the error, or simply you can say it will minimize the uncertainty in resistance. So these are practical points you need to understand about electricity experiments. Part B says the student measured values of x and corresponding values of capital R and plotted a graph of his measurements. State why the line of best fit does not pass through the origin. So first of all, we need to understand the question carefully. If you look at this question carefully, it means on this diagram, it is given to us x is equal to 0. It simply means that this rod is just next to this one. It's just next to ohm meter. So the ohm meter will give us the value of resistance, and that is resistance of movable rod, mean this rod. So simply we can say that is movable rod resistance. So ammeter will give us value of resistance of this movable rod. We can also talk about, when we say ammeter will only give us value of resistance of movable rod, it means we are assuming these connecting leads, they are ideal, but practically these connecting leads, they also have resistance. So the ammeter will show resistance of connecting leads. We can also talk about that point. So these are two valid points you can write down. So now let's try to understand a little bit about systematic error. This is a common point you can write down, systematic error. If there is a systematic error on the graph, how we will see that systematic error? We will see that one in form of y-intercept, mean there will be a y-intercept, or there will be x-intercept. If there is x-intercept or if there is a y-intercept, it means there is a systematic error. An example of systematic error is zero error. So this is systematic error. Example of systematic error is zero error. So these points we can talk about. Now let me explain you a little bit about random error. This is not part of this question, but it's important to understand random error as well. If there is a random error, we will see these points, they will be scattered more, means this point may be here, this point may be here, this point possible here, this point may be here. So in this case we will have more scattering of points. So we can say point scattered, they are scattered more, scattered points. This will tell us there is random error. So it's very important to understand the question. When you can picture question in your mind, then it's very easy to figure out the right answer. So how we can write down our answer? In our answer we can talk about these points. First thing we can say, when x is equal to 0, the ohm meter will measure the resistance of the movable copper rod. We can also say zero error in ohm meter, but in this case that is less practical. If you just write on that one, it means you just memorize something, but you need to understand the given experiment. We can also say connecting leads have a resistance. So if you write on any one point, you will get 1 mark. Part C says the total length L of copper in the circuit is given by L is equal to 2x plus 0.050 meters. The copper rods have a diameter of 3.0 mm. Determine the resistivity of the copper. So for this question, simply we need to calculate resistivity of the copper. So we can look at resistance, that is equal to rho L by A. We need to find out value of resistivity, so we can rearrange, we can write down resistivity will be equal to RA divided by capital L. Now the question is that we don't have value of R, we don't have value of L. So for that purpose, simply we need to look at this graph. We can take one value of X. So let's say this is our value of X, and at this value of X we can also find out value of R. So it simply means that you can read from here. So this is your X, and you can read resistance from here, and resistance in this case will be equal to 1.3, about 1.3. And now we can use these values and we can find the value of resistivity. So we have value of resistance, that is 1.3 times 10 to minus 3, because this is in millimeters, and cross sectional area will be equal to pi by 4. So we can write down this is pi by 4 d square, and value of d we have, that is 3.0 mm. So you have to multiply with 10 to minus 3 and divide it by square of this one, divided by value of L. So value of L is 2 times X. So we have X, that is 0.25, plus we have 0.050. This is value of L. So this is our value of L. Now if we just simplify, means if we calculate these values, we will get value of resistivity, that will be equal to 1.68 times 10 to minus 8 ohm meter. So this is how you can calculate value of resistivity in a very straightforward way. Part D says the safety system of the railway estimates the position of a train on the track using a resistance measurement. The rails become worn with continuous use, so their cross-sectional area decreases. Explain how the decrease in cross-sectional area affects the estimate of the position of a train. So for this question, it is given to us that cross-sectional area decreases. So simply we can start with resistance. Resistance is equal to rho L by A. We can rearrange, we can say R over L. This is equal to rho divided by A. Resistivity remains constant because this is property of material, and cross-sectional area in this case decreases. So it simply means that this ratio will increase, R over L. And R over L, this is representing the gradient. So this is representing the gradient. So it means gradient will increase. So simply we can redraw the new line. So new line may look like this. Now this is new value, we can say this is the new actually line, and estimation is done based on this. So estimation is done based on the previous line. Now if we draw the line here from, let's say from this point, so we will have two values of X. We have two values of X, one from the new one and one from the old one. So this is one from the old one. So we have these two values of X. Train will estimate based on this relationship, but we have got new value of X here. So this one will be the actual. So this is actual, and this one is estimated. So train will system, in the safety system of the train, it will give us this value of X because it will do calculations based on this previous relationship. So the actual value will be lower than the estimated one. So that's the point simply we need to understand. So X actual, this one will be smaller than X estimated. X estimated, or you can say X estimated means calculated by the train safety system, that will be greater than X actual. So these 2 points simply you need to understand. Now let me show you the answer, or you can write down your answer. In your answer, you can talk about these 2 points. We can say, as the cross-sectional area decreases, resistance per unit length of the track increases. The system will estimate the position of the train is further away than it actually is. Mean x estimated. This will be greater than x actual. So very straightforward one, but bit tricky one. So you need to understand this ratio will increase. When this ratio will increase, the line will be steeper. So one, we will get the actual value from this new line and estimate it from the previous line. Question 3 says, a student investigated how the speed v of the waves in water is affected by the depth of the water. She filled a 40.0 centimeters long plastic tray with the water to a depth d. She raised and released one end of the tray, creating a wave which traveled along the surface of the water as shown in the figure. The wave traveled to the far end of the tray and was reflected. The student had a meter rule and a stopwatch. Describe how the student could determine the accurate values for d and v. Accurate values for d and v. So first of all, for d, how we can determine accurate value of d. So the first thing we have to make sure, when we place the meter rule has to be perpendicular to this one. So it means that if we place our meter rule here to find value of d, so this one is our meter rule. So when we place this one here, it has to be perpendicular to this tank, to this tray. Mean this angle has to be 90 degrees. This angle has to be 90 degrees. How we can make sure this angle is 90 degree? For that purpose, we can use a set square. So we can place our set square here and we can make sure angle is 90 degrees. So this is one thing we can do. And also we can measure value of d at different places. We can measure value of d at different places along the tray, and then we can find the mean value. Different places, then we can find the mean value. So this is very common point whenever you take any readings, when you do any measurements, always repeat and take average. Different places, then we can calculate the mean value. We need to determine the v, and for the v we need this, we have this distance. So we have distance, so distance is given to us is, this is our d, we can say this is d1. So this is d1, this has to be divided by t. So for v we need to find out value of t. So for this one we can calculate value of t for the wave. So we can say time taken by the wave from this end to this end, that will be the time. So we can take that time and we can divide d1. d1 in this case is 40.0 centimeters, and we can divide by time. But we can also repeat time. So we can repeat for time. So we can repeat readings for time, and then we can find the average value of t. Average value of t. So simply we can say average value, and then finally we can divide 40.0 centimeters by t, time taken from this end to this end. So these are the points we can use in our final answer. So let me show you the answer, how you can write down your final answer. In our final answer we can mention these points. So first of all we can say, ensure meter rule is vertical. You can also say using set square. So this point you can write down using set square. Measure d in multiple places and calculate the mean. So if you write on this, you will get 1 mark and 1 mark for this one. Measure the time taken for the wave to travel the length of the tray, means from here to here, and repeat this one and calculate the mean value, and then calculate value of v using average time for the wave to travel 40.0 centimeters. So this is how you can answer. Quite straightforward question, how to measure time and how you can make sure time, calculated time is accurate, means the measure time is accurate. So we can repeat time, we can take more than one readings for the time, and then we can calculate average value. Is a very common point, all the time we do this one. And how we can make sure value of D is correct? We need to make sure meter rule, when we place along the tray, it has to be vertical. How we can make sure meter rule is vertical? We can use simply set square. And also we have to take value of D at different positions. So we have different positions, and then we can take mean of that. That is the best way to measure depth. Part B says the student was given a formula for the speed of water waves, where k is a constant. Describe how the student could use a graph to determine a value of k. So if you look at this given formula, simply we can compare this one with y is equal to mx. So our quantity on y-axis has to be v square, and quantity on x-axis, if this is d, then the gradient will be equal to m is representing gradient, so gradient simply will be equal to k. So we can calculate value of gradient. So simply if we sketch a graph between v square on y-axis, and if d is on x-axis, the relationship between these two quantities, it has to be a straight line, and the gradient of this one will be equal to k. So this is how we can find value of k. So we can simply say plot a graph between v square, and v square should be on y-axis, and d on x-axis. So in this case, gradient is representing k. So that's all what we can write on. This question has only 2 marks. If you write on these 2 points, you will get 2 marks. So you will get 1 mark for this one and 1 mark for this. Second part says she determined the speed v of the wave for 3 depths of water. She calculated the value of k for each depth. Criticize the recording of these results. So first of all, we need to understand this is over measured data. So we can say this one is the measured data. This is also measured, but this one is calculated. So this is our calculated data. So we can say this is calculated data. Measured value, they should have same TP. So it's very important one. All of them, they should have the same TP, because we measure them using the same instrument. So because we measure them using same instrument. And calculated data, it should have the same SF. It's better to keep same number of significant figures. Now if you look at first column, the value of this has 1 dp, but they do not have dp. They do not have 1 dp. It means that these values are inconsistent decimal places. So this is wrong way to write on. This is telling us we are using one instrument, and this is telling us we are using a different kind of instrument. So when we do one experiment, we will be using the same instrument. So we have to keep the same number of decimal places. So these are consistent decimal places. And if you look at the second one, all of them, they have the same number of dp. So it means that these values are consistent. But if you look at these values, they should have the same SF, but they do not have same SF. I mean, they have inconsistent SF values. So we can criticize this, inconsistent SF. So these 2 points we can write on. This question has 1 mark. You can write any one of them, but the best point is this point. They should have same dp, because we are using the same instrument. But you can also talk about SF as well, inconsistent SF. They should have the same SF. So in our answer, we can talk about these 2 points. So these are valid point. The first one is very practical one, because this tells us about the instrument we are using. So you can talk about this one, you can also talk about SF as well. Third part says the student suggested that the value of K should be equal to gravitational field. Discuss whether it is likely that K is the gravitational field. Your answer should include calculations. Mean we have to prove this one with calculations. For this question, it was given to us that K is equal to 9.9 and K is equal to 9.36 and K is also equal to 9.88. This is given in the last part. So first of all, we can calculate the mean value of K. So we can calculate mean value of K. So simply we can say 9.9 plus we have 9.36 plus we have 9.88 divided by number of measurements. So the final answer will be equal to 9.71. And value of G, the accepted value of G, we have that is equal to 9.81. Now simply we need to calculate the percentage difference. So we can say the percentage difference in this case will be equal to the difference between, so let me write down in a proper way. Most of the time students, they get confused with that. So we need to write down difference in calculated and accepted value. Calculated and accepted value, and this one we have to divide by the accepted value. Means we are comparing with G, so we have to divide by G. Accepted value, we are doing comparison with G. So simply in this case we have to find the difference. So we can say 9.81 minus 9.71. So this is the difference between G and mean value of K, and we need to divide by G. So G is equal to 9.81, and we need to multiply this one with 100 because we are talking about percentage difference. So if we do this one, our final answer will be about 1%. And 1% is very small. This one is very small percentage difference. So we can say, so K could be G. K could be G. So this is how we can answer this type of problems. Percentage difference. So you have to find the difference in calculated value and accepted value of G. And as you are comparing with G, so you have to divide by G, means the accepted value of G. Question 4 says a student investigated the photoelectric effect using the apparatus shown in the figure. He used a source of white light and color filters to shine different wavelengths of light onto the photo cell. The table shows the student's data. For part 1, plot a graph of Emax on the y-axis against 1 over lambda on the x-axis on the grid opposite. Use the additional column of the table for your process data. So simply we need to sketch the graph between Emax and 1 over lambda. So first of all, we need to calculate value of 1 over lambda. So 1 over lambda has to be in this column. So we can say 1 over lambda. So 1 over lambda, simply we can write down, this will be equal to 1 over, we have 620 nanometers. So this is 10 to minus 9 meters. So this is in meters now. So if we solve this one, we will get 1.61 times 10 to 6 per meter. So we can take this factor out. So we can write down here. So this is 10 to 6 per meter. And we can do the calculations and you can write down all the values here. So this is 1.61. This has 2 SF. This one has 2 SF. So you can use 2 SF here or you can use 3 SF here. I'm using 3 SF here because this one has 3 SF, this has 3 SF, this has 3 SF. So these SF values have to be consistent, so we will be using 3 SF in this column. So the final answer, if you have done these calculations, you will get these values. So we can write down these values. So this is our final values. So you see it has 2 SF, we have used 3 SF here, 3SF, we have used 3SF, 3SF, 3SF. So these are consistent SF values. So this is one thing important, you have to take care of this one as well. Now we need to sketch the graph. Sketch the graph, Emax on y-axis, 1 over lambda on x-axis. So the first thing is the scale. Actually scale is very important. Scale for y-axis. Scale for y-axis. So we have the maximum value, that is here, maximum value. This one is the minimum value. So simply we can calculate range. First of all, we have 13.9 minus we have minimum 5.6, and we can divide this one by the number of these big square. So we have 1 2 3 4 5 6 7 8 9 10 11 12. So we can simply divide this one by 12. So we will get 0.69. It means that one big square we can take, one big square we can take about 1. So we can take about 1, means the difference can be 1. And for the x-axis, we can follow the same method. So we can choose the scale. So we can take the maximum value, that is 2.29, minus you can get minus minimum value, and this has to be divided by number of big square here, 1 2 3 4 5 6 7 8. So we can divide this one by 8. So we will get 0.085. So we can simplify this one. So we can say we can take about 0.1. Keeping this in mind, we can sketch the graph. We no need to start this one from the origin. So we can start this one from, this is 1.61. So we can start from 1.60, and the next one will be 1.70. Then we can go to 1.80 and so on. And for this one, the minimum value is 5.6. So we can start from the 5, then we can go to 6 and so on. So this is how you can label the scales. Label these axes and you can choose the scale. Now if these things are okay, we have chosen the scale. Now simply we can plot these points, and if we plot these points, our graph should look like this. And also it is very important, you have to write down the quantity and you have to write down the unit as well on x-axis and also on y-axis. Now let's try to understand how these 6 marks will be awarded to you. The first mark you will get if you have calculated correct values of lambda and you have rounded these values to 3SF, you will get 1 mark. And the second mark you will get if you have labeled x-axis with quantity and unit and also y-axis with quantity and unit, you will get the second mark. And the third mark you will get if you have a sensible scale. Sensible scale means that when you draw this best fit line, it should cover more than half of the graph along x-axis and more than half of the graph along y-axis. So it simply means that in this case we have 1 2 3 4. So the graph has to be along x-axis at least more than this line, means more than half, and also along y it has to be more than half. So 1 2 3 4 5, it has to cover greater area than this area. So that is a sensible scale. So in this case our scale is also sensible, so you will get 1 mark for sensible scale. So we can say more than half. So your graph cover more than half on x-axis and more than half on y-axis, I mean this best fit line. And next mark you will get for the plotting. If you have plotted these points, you will get 1 mark for the plotting and another mark for line of best fit. Line of best fit, you will get another mark. So this is how these marks will be awarded to you. Second part says the relationship between the maximum kinetic energy of the emitted electrons and the wavelength of the incident photons is given by this equation. Show that the Planck's constant is equal to gradient of the graph divided by c. So first of all we have to rearrange. So we can write down Emax in this case will be equal to hc over lambda minus we have this is the work function. So this is how we can rearrange. We can also write down this one in a proper way. We can say hc times 1 over lambda minus we have this is the work function. So here we have this is Emax, means the maximum kinetic energy of emitted photoelectrons. Now simply we can compare this one with straight line equation. So hc here, this is equal to the gradient, and quantity on y-axis we have Emax, and quantity on x-axis we have 1 over lambda. So this is over x. So from here we can say that gradient, so we can say gradient from here is equal to h times c. So h from here we can say is equal to the gradient of the graph, so we can say gradient divided by c. So this is what we need to prove actually, and this question has 2 marks. So if you have rearranged in this form, you will get 1 mark for this one, and if you have compared with y is equal to mx plus c, you will get the second mark. For our third part, we need to determine a value of h, a value of Planck's constant. We have already discussed in the second part that Planck's constant is equal to gradient of the graph divided by c, and c is a constant, and this is equal to 3.0 times 10 to 8. So simply we need to calculate value of gradient. If we have value of gradient, then we can determine value of Planck's constant. So simply we need to calculate gradient from this graph. We can choose 2 points on this line. Let's say I take this point, and another point I can take here. Don't draw a very small triangle. Triangle has to be large enough, larger than the hypotenuse of the triangle has to be larger than half of this line, So if I choose this point and I choose this point, so this is quite reasonable. So we can draw this triangle. So simply we can draw here. So this is triangle. We can also write down the coordinates here. So we have x here, that is 2.20, and y coordinate will be equal to 12.8. We can also write down coordinates of this point. We have 1.70, and we will have y 6.6. Now we can calculate gradient. So we have 12.8 minus 6.6, and this is multiplied with 10 to minus 20 divided by, we have x values, that is 2.20, minus we have 1.70, and this is multiplied with 10 to 6. Now if we solve this one, we will get value of gradient, that will be equal to 1.24 times 10 to minus 25 joules meter, and this value we can plug in here simply. So this is 1.24 times 10 to minus 25, and if we solve this, we will get 4.13 times 10 to minus 34 joules seconds. So this is the final answer. So simply you need to calculate gradient, then plug in values, and you can find the answer. But one thing you have to be careful, these points should not be very close. The distance between these 2 points you have chosen has to be more than half of the length of the line. So this is very important point to minimize uncertainty and to improve the accuracy. So the answer for this question is 4.13 times 10 to minus 34. For part 4, we need to calculate the percentage difference between h and the accepted value for the Planck's constant. We have calculated value of h in the last part, that was equal to 4.13 times 10 to minus 34, and value of Planck's constant, accepted value of Planck's constant, we can say h accepted, the standard value you can say, that is equal to 6.63 times 10 to minus 34 joules second. Now simply we need to calculate percentage difference, so we can write down percentage difference. In this case we are comparing with the accepted value, so we have to divide by the accepted value, very important one. We are doing comparison with this, so this is 6.63 times 10 to 34 joules second. Here we need to find the difference, so 6.63 times 10 to minus 34 minus we have 4.13 times 10 to minus 34, and we have to multiply this one with 100 because we are calculating percentage difference, and if we solve this one we will get 38%. So this is percent. So that's all. This is the answer. Part B says the student's investigation involves a small random error and a large systematic error. For each of these, suggest a source of the error and a realistic modification to the procedure which would reduce it. First of all, for the random error. In this case, we need to determine the stopping PD. If you read question part A, it is given to you in detail. Stopping PD. And stopping PD is the value of PD when current is equal to 0. And it is not easy to find out when current is equal to 0 using the given apparatus. So how we can modify apparatus? We can use micro ammeter, means we can use more sensitive ammeter, so it will reduce the uncertainty. By using more sensitive ammeter means we can use pico ammeter or we can use micro ammeter, so we can see the small changes. So we can say more sensitive ammeter. By using more sensitive ammeter we can minimize uncertainty. So that's all you can say for the random error. And for the systematic error can be due to the zero error. So this one can be due to zero error in ammeter. Zero error in ammeter. So we need to check ammeter reading has to be equal to 0. So we can say ammeter reading has to be equal to 0 when no light. When no light shining on the photo cell. So these 2 points we can mention. We can also talk about the color, but these 2 points are very easy to understand. This part needs your understanding of photoelectric effect experiment. If you don't have understanding, it will be hard for you to write on this point, but this point can be easier one. Now let me show you the answer, or you can write down your answer. So these are the points you can mention in your answer. So this is reading, means this is reading. So we can say difficult to judge exactly when current becomes 0. So exact stopping PD is difficult to identify. So use more sensitive ammeter. And for systematic error, we can say zero error of the ammeter. We need to check ammeter for zero error, and we need to make sure ammeter reads 0 when no light is shining on the photo cell. We can also talk about color filters, because in this case we are using color filters to get one value of lambda. So we can say color filters do not give monochromatic light. So it's better to use monochromatic light source directly instead of white light. In this case we're using white light, then we're using filter, but filters do not give exactly monochromatic light. So for this experiment it's better to use monochromatic light instead of white light. And that's all for today's lesson and also for this paper. If this video was helpful, please like and subscribe, because your encouragement is very important. And also leave some comments in the comment section, and if you have any questions you can also leave your questions in comments. And for more help and more resources, please join Patreon, and the link for Patreon you can see in the description of this video. Means the link is in the description of this video for Patreon. You can simply click on that link, you will go to Patreon. So join Patreon for extra help and more resources. On Patreon you will find a lot of extra resources, especially topic wise questions, worksheets with detailed solution, and also videos, and also extra resources.